Now, in this example, we will perform a modal analysis on an assembly. In the previous examples, we have seen how to perform free vibrations and free vibrations on 3D models and on 2D models. Now here we will be performing modal analysis on an assembly. You can see that the dimensions of the assemblies are mentioned over here. These are three different components that are used in the assembly, okay, and the assembly is fixed at the 4 holes over here, and we need to find out the natural frequency of the assembly. So first we will create the assembly and then we will perform the modal analysis. So let us add one modal analysis system, and I will say modal analysis, rename it. The material that we have to use for the models is aluminium alloy. So let me add the aluminium alloy. Now we will enter into the geometry. As you can see over here that the unit system for the length is inches. So let us set the unit system as inches. And now let us start creating the design. So let me first click on the ZX plane, and now we will enter into sketching. I'm going to create the first base plate over here like this, which is 5 inches by 2.6. Okay. So I'll use a rectangle, and now we will give the dimension. So this is 5 inches, and this is 2.6 inches. Constraints, we will add one symmetry constraint for this, and similarly we will add another symmetry constraint over here. After that we will extrude this model, select the sketch, apply, and the depth will be 0.2 inches, and we will generate, and I will call this model as the base plate. This is the first model. Similarly, now we need to add the second model as shown over here. Okay, so I am going to come to design modeler. You can see the dimensions. 6.75 inches is the distance. So we will select this face over here and then enter into the sketching tab. Okay. Now look at the model. The distance from this edge to the center is 0.875 inches. So I'm going to draw a circle whose horizontal dimension from this point to this is 0.875 inches. Okay, and then I'm going to draw one line from here which is tangential, and the dimension of this line should be 6.75 inch, and it should be coinciding, this line should coincide with this. Now let me add a dimension for this diameter. So diameter of this model is 0.2 inside, and outside is radius 0.625. Okay, let me add the radius for this. It should be 0.625, and we need one more circle inside whose diameter is 0.2. Okay. Now we need to create the same at a distance over here. So I can create a line, the vertical dimension between this and this, it has to be 0.625. So I will add this dimension 0.625, and then in modify we will use the copy option, right click, set paste handle, select it from here and paste it over here. After that you can delete this and add one more line from here to here. Once this is done, you can come to modify and trim whatever is not needed. Okay, and then come back to the modeling tab and add the depth. So I need a depth of 0.2, but here it is going to be add frozen because it is an assembly. Now we need the same part on the opposite side. Okay, so if you look at it, if you look at the YZ plane over here, okay, I can use the body operation mirror. Bodies will be this, and mirroring plane will be YZ plane, and generate. So this is the assembly that we've got, and I will call this as the left arm, and this is the right arm. So with this, now we have created our assembly. So this is the assembly that we needed. Now we will take this assembly into the mechanical window. So come to the mechanical window. So this is the assembly that we needed. The assembly is ready. First, give the material. Because all the parts have the same material, I can select them simultaneously and change the material. After that, we can come to the meshing. Before meshing, we need to assign the contacts. We have two contact regions, and both of them, I will say, have bonded contacts. There is no movement. That is why I have selected them as bonded contacts. After this, we will select the mesh option and we will update the meshing. Initially, we'll get the default meshing. You can see that the meshing has come, but if you want, you can control the sizing for individual bodies. Okay, over here I say that the element size is 5. Look at the meshing. Okay. So now that the meshing has been done, we will now come to the modal option and we will add the supports. So as per the problem description, 4 holes are fixed. Okay, so I have selected the 4 holes and we have applied the fixed support. In analysis settings, I will say that I want the first 3 vibrations. And after that, we will come to solution option and we will solve the analysis. So the analysis procedure will take time over here because it's an assembly. After that, you will see that the frequencies have been recorded, the first 3 frequencies. I'll select all and I will create the mode shapes and again solve this. Now you can see the vibrations and the mode shapes. So these are the vibrations and these are the mode shapes that we are getting. Okay. So this is how you will perform a modal analysis on an assembly.